A metal extracted from its ore by any method is generally impure and is known as crude metal. The impure metal is purified by subjecting it to a process of purification or refining. Depending upon the nature of the metal and the impurity present, various refining methods such as distillation, liquation, electrolysis, zone refining, vapor phase refining, and chromatography are used. Let's look at each one of these techniques in detail. First, let us study distillation. This process is used to purify metals with low boiling points, such as zinc, cadmium, and mercury. In this method, the impure metal is heated in a retort and its vapors are separately condensed in a receiver. The pure metal distills over, leaving behind the non-volatile impurities in the retort. Let's look at another refining method, liquation. This method is used when the impurity is less fusible than the metal itself. In this technique, an impure metal with a low melting point, such as tin or lead, is heated at just enough temperature to melt it using a sloping hearth. The impurities with higher melting points do not melt and stay at the top of the sloping surface, while the molten metal flows down, thereby separating it from the impurities. Another important refining method is electrolysis. In this method, the impure metal is made the anode and a strip of the same metal in its pure form is made the cathode. An aqueous solution containing a soluble salt of the same metal is used as the electrolyte. On passing electricity, pure metal is deposited on the cathode. The more basic impurities go into the solution, while the insoluble impurities, particularly the less basic ones, settle at the bottom of the anode as anode mud. For example, copper is refined by the process of electrolytic refining. Impure copper metal is made the anode, while a thin strip of pure copper strip is made the cathode. An acidified solution of copper sulfate is taken as the electrolyte. On passing electricity, copper atoms from the impure copper anode lose electrons to become Cu2+ ions and enter the electrolyte. These metal ions are reduced at the cathode and are deposited as pure metal. The more electropositive impurities like iron, nickel, and zinc are left in the electrolyte as their sulfates, while the less electropositive impurities like gold, silver, and antimony settle at the bottom of the anode as anode mud. Precious metals like gold and silver can be recovered from the anode mud. Other metals like silver, zinc, lead are also purified by this method. Let's now study the zone refining technique. This technique is based on the principle that impurities are more soluble when the metal is in its molten state than when it is in its solid state. This technique is used for obtaining metal with very high purity. The process is carried out in an inert atmosphere to prevent the metal from getting oxidized. In this technique, a movable circular heating roller is fixed at one end of a rod of impure metal. The metal melts in zones called molten zones as the roller moves towards the other end of the rod. When the heating roller shifts forward, the metal to the left cools down and crystallizes, while the impurities dissolve in the molten zone. In this way, the impurities keep shifting along with the molten zone to the right, and pure crystallized metal is obtained on the left. The process is repeated several times till the impurities are completely removed. Elements such as germanium, silicon, and gallium, which are used as semiconductors, are refined by this method. In another refining technique, which is vapor phase refining, the impure metal is first converted into its volatile compound. The volatile compound is then decomposed to give pure metal. It is essential for this technique that the volatile compound of the metal should be easily formed and easily decomposed. Let us consider nickel. Nickel reacts with carbon monoxide to form a volatile nickel tetracarbonyl complex at a temperature of 330 to 350 Kelvin. The nickel tetracarbonyl is then heated to 450 to 470 Kelvin, where it decomposes to give pure nickel and carbon monoxide. This method is known as Mons process for refining nickel. Another example of vapor phase refining is the Van Arkel-de Boer method for the purification of titanium and zirconium. In this method, titanium or zirconium, which contain oxygen and nitrogen as impurities, are heated in an evacuated vessel with iodine to form the volatile titanium tetraiodide or zirconium tetraiodide. The metal iodide is then decomposed on a white-hot tungsten filament at 1800 Kelvin to give the pure metal. Now let's move on to the last refining technique, chromatographic methods. In these methods, the metals and the impurities are separated by the difference in their relative adsorption with an adsorbing medium. The mixture to be separated is applied onto a stationary phase. And a mobile phase is allowed to run slowly over the stationary phase. The components in the mixture get partitioned between the mobile phase and the stationary phase, and thus get separated. Depending upon the physical state of the mobile phase and the stationary phase, and also on the passage of the mobile phase, different chromatographic methods, such as paper chromatography, column chromatography, and gas chromatography are used. Let us take a look at column chromatography, which is particularly useful for the purification of elements that are available in minute quantities, and the chemical properties of the impurities are not much different than that of the element to be purified. In this method, alumina or silica gel is packed in a column and serves as the stationary phase. The mixture to be separated is placed on the top of the column. a suitable eluent is allowed to flow down the column slowly. Depending upon the degree to which the components in the mixture are adsorbed, complete separation takes place. Let us now study the uses of some commercially important metals such as aluminium, copper, zinc, and iron. Aluminium foils are used as wrappers for chocolates, medicines, and food items. Aluminium dust is used in paints and lacquers. Since aluminium is more reactive than chromium and manganese, it is used in the extraction of these elements from their oxides. Aluminium is used to make electrical wires as it is a very good conductor of electricity. Aluminium alloys are light and are very useful. For example, gamma alloy and duralumin, which are alloys of aluminium, are used for making aeroplane parts. Copper is used for making electrical wires. Copper pipes are used in homes and industries to carry water and steam. Copper forms alloys such as brass with zinc, bronze with tin, and coinage with nickel. These alloys are harder than copper and have many domestic and commercial uses. Zinc is used for galvanizing iron. Galvanized iron does not corrode and is used to make pipes, roofs, I-beams, fences, and wires. Zinc is extensively used in carbon-zinc dry cells or batteries. Zinc forms alloys such as brass with copper and German silver with copper and nickel. Brass is used in musical instruments, doorknobs, and ornaments, while German silver is used to make silver-plated cutlery, idols, and jewelry. Zinc dust is used as a reducing agent in the manufacture of dye-stuffs and paints. Cast iron, the most important form of iron, is used for casting stoves, railway sleepers, toys, and gutter pipes. It is also used in the manufacture of wrought iron and steel. Wrought iron has several uses. To name a few, it is used to make anchors, wires, gates, bolts, chains, agricultural equipment, and furniture. An important alloy of iron is steel, which has many domestic and industrial uses. Different varieties of steel can be obtained by adding other metals like nickel, chromium, cobalt, and manganese to it. For example, nickel steels, which have varying amounts of iron and nickel, are resistant to wear and tear and can withstand mechanical shock. Hence, nickel steels are used for making cables, automobile, aeroplane parts, pendulums, and measuring tapes. Similarly, chromium steels, which are extremely hard and resistant to wear, oxidation, and corrosion, are used in armor plates, cutting tools, crushing machines, and stainless steel for cycles, automobiles, utensils, pens, cutlery, and surgical instruments.